Welcome back to my channel. These questions was asked by MIT Integration B qualifier in the year 2020, and this is question number 17. In this integral, we have limit from 0 to 1, and then here this pi, capital Pi, stands for product of this. Now here k goes to infinity. Here we have 1 plus x raised to 2, and then here 2 raised to k is over here. You can see 2 raised to k over here. Now let's consider only this part. Okay, let's consider what is 1 plus x raised to 2k when k goes from to infinity with product. Let's see. Let's consider this product pi 1 upon 1 plus x raised to 2k, where k goes from 0 to infinity. Now let's substitute when k equals to 0 is equals to, when k equals to 0, what we have? 1 upon 1 plus x raised to 2 raised to 0 into, since product is pi is there, so we'll get into 1 upon 1 plus x raised to 2 raised to 1 into 1 upon 1 plus x raised to 2 raised to 2, and here and 1 plus x raised to 2 raised to, here 0, 1, 2, 3 and so on up to infinity. Okay, so what is this? Here 1 plus x 2 raised to 0 is what? 2 raised to 0 is 1. So I can say this is x. Okay, and then into 1 upon here 1 plus 2 raised to 1 is what? 2, and then here 1 plus 2 to the x raised to 4, and similarly here we have 1 plus x raised to 8 and so on. Okay, now let's multiply these first two terms. Let's see what happens. Okay, if you multiply these first two terms, let's see, then here 1 plus x into 1 plus x square is what? See, this is 1 plus x square, and then plus x, this into this and this into this, so x plus x cube. So what we have, this same as 1 plus x square plus x cube. Okay, this is what first two terms. Okay, now if we consider first two terms, then its multiplication is this. Now if we consider these first three terms, okay, now if we consider first three terms, then this into this will come here. Okay, so here 1 plus x square plus x cube into 1 plus x raised to 4. Okay, so here we'll get 1 plus x square plus x cube plus, let's multiply this, x4 plus x5 plus x6 plus x raised to 7 here. So similarly whole terms will be what? Similarly, so this okay, now you can see in the first two term we have up to x3. Okay, here up to x3, and then third term is here you'll have this. Okay, so it's keep on increasing. So similarly we have whole this denominator, what we have is 1 upon 1 plus x square plus x cube and so on. Okay, up to infinity. Okay, so this. Okay, therefore this equals to this we have. Okay, now let's consider only this denominator. What is its sum? Okay, what is 1 plus x square plus x cube up to infinity? What is sum of this? Okay, what is 1 plus x plus, let's consider, we can say consider denominator. Okay, this denominator 1 plus x square plus x cube plus and up to infinity is what? Remember we have geometric progression. Okay, sum to infinity term is what? A upon 1 minus r. Okay, what is A? A is first term first term of GP, and R is what? Common ratio. Okay. The sum to infinity, GP of sum to infinity is given by this. Okay. Now, if this sequence, okay, now here this is GP, okay, now here first term is what? 1 and common ratio is x. So by applying this formula for GP, the sum of infinity is given by A upon 1 minus R, okay, and now A is what? First term, R is common ratio. Now for here first term is what? Our first term is 1 and common ratio is CR, you can say common ratio is x. Therefore this sum to infinity is given by A first term is 1 upon 1 minus x. Okay. So hold this. Okay. Now hold this denominator. Sum is equals to 1 upon 1 minus x. So this part. Okay. Now hold this part. Now hold this part is what we are getting? 1 upon 1 minus x. So 1 minus x we can send off. So is equals to integral. All this is what we have, 0 to 1 upon 1 by 1 minus x into dx. So I can send this off, is equals to integral 1 minus x 0 to 1 dx. So this integration is what? Integration of 1 is what? X minus x square by 2 and limit is from 0 to 1. Okay. Is equals to, if I substitute upper limit 1 minus half. 1 minus half is what? Half. Half is the required answer for this question.